We're going to try to apply some of those properties. So what we're going to do is we're going to find the limit of a function of as x approaches c, okay, of x cubed plus 4x squared minus 3. Okay, so now we're just going through the phases how we would normally do this. This is just a regular polynomial. So we could do this a lot of ways. We could plug in the whole equation, graph it, and look at it as it approaches c. But really what we could do is we could think of this as being the same as the limit of x cubed as x approaches c plus the limit of 4x squared as x approaches c plus the limit of negative 3 as x approaches c. By the way, is there any x term in that last one? No. So whenever we take the limit of a constant, the limit is just the constant, right? So I'm not going to write that there because it looks like the whole thing equals 3. Okay? I just wanted to share that with you. So now what I could do is I could plug this in, and this whole limit then could equal the limit of c cubed, right? But when I plug in the c, I don't have to have limit notation anymore. I could just say c cubed plus, what's the next thing? 4c squared plus, now the limit of a constant is just itself, which is negative 3. And so that is the limit. Now you say, Mr. Adams, couldn't we just plug in the c? Well, you want to, we're going to ramp up to the harder stuff. So let's start with something that's real easy and simple to follow, and then when it gets more complicated, we'll go from there. Yes?
I think class is over.
It's possible. Let's do example number 4.